Okay, great. We have 10 attendees. Do let me know if there is any message asking them to invite. Okay, ladies, so let's start with the value of this week, which is cooperation. So inshallah, we'll discuss about the importance of cooperation for the first 7-8 minutes, and then we shall start our lesson, inshallah. Right? So let's start. So what is cooperation? Ladies, what do you think is cooperation? Can someone tell me? Dareen, can you tell me what is cooperation?
I actually don't know.
You don't know? All right.
Yes.
Hannah, no problem, sweetie. I'm going to explain it to you now. Hannah Adil, would you like to tell me what is cooperation according to you?
Miss, cooperation means like working in a group, like together.
Working in a group together. Yes, thank you, Tulan. Yes, we can say that is cooperation. Working together, helping each other, giving each other support. All this is cooperation, isn't it? Thank you so much, Tulan. Anybody else who wants to add on to that? All right. So yes, that was very well said by Tulan. As you can see in this picture, there are 4 people who are trying to work on something, and this is possible only when 4 of them, they work together, cooperating each other, isn't it? All right, so cooperation is the action or process of working together to the same end, meaning in order to complete a task, you are working together, meaning you are cooperating with each other. Isn't it? So there are many things which need cooperation. It is very, very important because if we start from your home, you need to help your mother with the chores. You need to help with your young siblings. You need to help your parents, your sisters, everyone, and only then your family can run. Right? You need to cooperate with each other. You need to help your elders in the family, like your grandparents, your parents. So with the cooperation of each and every family member, a family can run or work smoothly, isn't it? Similarly, if we are talking about your class, so all the students in the class, all of you, you need to cooperate so that a teacher can teach you, or so that you can together accomplish many tasks, isn't it? So this is the meaning of cooperation, the action or process of working together in order to achieve something, in order to attain something, or towards one thing at the same end is known as cooperation. All right. So why is cooperation important? Now that you know the meaning of cooperation, can someone please tell me how important it is, or why is it important?
Because without it, nothing will be organized.
Excellent. Very good. Very good answer, sweetie. Who was that? Tulan again. Who answered?
Yes, it's me.
Yeah. Yes. Thank you, Tulan. Yes, very good. Without cooperation, you cannot accomplish anything.
And it may be hard on yourself.
Very good. In order to accomplish something, it will be very, very hard if you're not cooperating with each other. If you're fighting with each other, if you don't want to help each other, then definitely the task will not be complete. And as Maya said, it will be very, very difficult, isn't it? Yes. So cooperation is very, very important in order to accomplish something, in order to do a task. Alone, we are smart. Together, we are brilliant. Isn't it? So whenever you are in a group, you can achieve many things together with the help of cooperation and helping and supporting each other instead of you being alone, isn't it? So there are many examples where in the larger the group, the more you can achieve, like a class, an entire family, or the entire group. So all the people, if they work on it together, then you can achieve that. Good morning, sweetie. Who is it?
Ramajat.
Ramajad, welcome to the lesson. I
Me
don't
too,
see
ma'am.
many today here. Yeah, even Hannah Tawfiq just joined. Okay, welcome to the lesson, sweeties. We are discussing about the value of this week, which is cooperation. So we will discuss it for about 2-3 minutes more, and then we'll get on with our topic, inshallah. So alone we are definitely we can achieve many things alone, but we are talking about the major tasks we need to accomplish in our life. Like if we are doing anything globally, like trying to protect our environment, okay, trying to stop pollution and such major things, trying to keep your classroom clean, yeah, and also trying to keep your house clean, or trying to take care of everyone at your home. So all these tasks can be done only if you're working in a group. Okay, so in a group you are together working, and you are working it together brilliantly by supporting each other than you are doing it alone. You could accomplish much more if you're working together in a group as a team. Okay, so that is what team means. Together everyone achieves more, isn't it? So if you compare anything which you are achieving individually to something which you are achieving as a team, you can achieve way more compared to what you've done alone. Okay, so whenever you are working as a team, you need to understand each other, you need to support each other, and you need to cooperate each other, and only then your team will win, right? For example, even when we are doing any quiz, we are dividing your class into team A, B, and C. So you are the ones who all are under team A. They need to cooperate with each other, and they need to discuss the answers, and only then they can win, isn't it? Each and every team, if it cooperates with each other, only then it will excel, rather being aloof from each other. If they are not cooperating, if they are not helping each other, definitely that team will not win, isn't it? So that is the definition of a team. Together everyone achieves more. Okay, so why is cooperation important? Cooperation is important because it allows people and groups to work together to achieve a common goal or derive mutual benefits. And cooperation exists at many levels and takes place between individuals and organizations, as well as between states and countries. As I just told you, if we are trying to fight a global issue like pollution, or trying to protect the world from this global warming or the plastic pollution, or we are trying to stop the forest fire. So all these are the global issues for which all the countries, they need to work together, isn't it? And if it is any issue of Saudi Arabia, all the cities in Saudi Arabia, they need to join hands and work towards a common goal, isn't it? So it can be a bigger problem at a very bigger level, at the global level, or it may be a small problem confined to your friends group, or confined to your family or your classroom. So whatever it is, when you are a team, you need to cooperate with each other, right? So it helps you to work together, it helps you to achieve better and derive more benefits compared to working alone. Okay, sweeties, that is about cooperation. We'll discuss about the rest of the presentation in your further lessons, inshallah. So let's get back to our topic today, which is energy. Right? So we are still doing energy, and today we'll be doing page number 219, 219, and 220, inshallah. Okay, so let's start with the verse from the Quran, which says, "See you not that Allah has subjected to you, that is all mankind, all that is on the earth, and the ships that sail through the sea by His command. He withholds the heaven from falling on the earth except by His leave. So verily Allah is for mankind full of kindness and most merciful." So this is a verse from Surah Al-Hajj, verse 65, in which we clearly understand the power of Allah. Allah is the creator, and He has the command over the earth and the heavens, and He can do whatever He wills. Okay, and whatever He does, there is wisdom in it. So we always need to put our trust on Allah. And also we need to fear Allah and love Allah both at the same time, because Allah is full of kindness, most merciful. Subhanallah. So the objectives of the topic today is we are going to talk about how the energy changes from a form to another form once we complete the electromagnetic energy and the light energy. So these are the two last energies left. After discussing this, we'll be discussing about the energy changes, inshallah. Under the KWL, let me ask you questions about the types of energy we discussed in the last lesson. We discussed about the electrical energy in the last lesson, isn't it? And we were discussing about the internal energy. So can someone please tell me what is internal energy? Girls, can you view the PowerPoint here?
Yes, miss.
Okay. Who's going to tell me what is internal energy?
Internal energy, like the number of kinetic energy with potential energy. Like when example, solid, liquid, and gas. Gas has more high internal energy, but solid has low internal energy. Because the solid has low movement, less movement, but the gas is really have more movement.
Yes, excellent. That was very well explained. Yes, of course, the gases, they have the higher internal energy than solids. Why? Because the particles, they can freely move around in a gas, isn't it? This we discussed in our chemistry already under the particle theory, which clearly states that the particles in a gas, they can freely move compared to the liquids and solids. But are the particles vibrating even in solids and liquids?
Yes.
Yes. In liquids, they are moving over and above each other. Yes, we can see the particles vibrating. And in solids, also the particles are vibrating, but in that case itself, they are vibrating without moving. All right. So this internal energy, you can define it as total kinetic energy plus total potential energy. So when we are comparing the internal energies of solids, liquids, and gases, the gases, they have the higher internal energy than a solid or a liquid because the particles in a gas are further apart, which means they have more potential energy and they have more kinetic energy, meaning they can move more freely compared to a solid or a liquid. Clear about the internal energy, girls?
Yes, miss.
Yeah, great. Now we were discussing about the forms of energy, in which I believe I gave you research in order to Google and tell me about the types of waves the types of waves which we use in the various things in our day-to-day life, like microwaves or radio waves or infrared radiation, as to where we use it. Did you research about it?
I totally forgot, miss. I thought you were going to write on the group, but I totally forgot, sorry.
Oh, okay.
Yeah, the last due date.
Yeah, I was supposed to write it on the group, but did I ask anyone to write about it? Even I totally forgot about writing it on the group. Okay, never mind. Did anyone happen to research about it or no? No one did it?
Miss, I researched.
But like, what happened?
I researched and sent it.
You researched? Yeah, please tell me, sweetie. Do you have anything to present or you want to speak about it?
I just sent it to you, like, it's a colorful one. Like, on Thursday, I sent it to you.
You sent it to me?
Yes.
Who is it, sweetie?
Maya.
Maya.
Or things like gamma rays and that stuff. I write.
Okay. I've been so busy over the weekend. Maya, let me check. Give me a moment, sweeties. Where is it, Maya?
first one.
This is the first. Yeah, I'm checking the first one itself, sweet. You want me to go down?
Yeah.
Uh-huh. This one?
No.
This is the homework.
Bottom. It's bottom.
Okay, this one?
Yeah.
Oh, wow. But this is about chemistry, I believe. Acids and alkalis. Did you research anything about physics, sweetie?
Physics?
Yeah, this is about chemistry. Yeah, I did ask you to research about chemistry also, Maya, about the types of chemicals which we use in our day-to-day life, isn't it? Thank you so much. I'll discuss about this in our chemistry lesson, inshallah. Did anyone else research about the physics thing? Okay, never mind if you did not. So let's discuss about it now without wasting further time. All right. So these electromagnetic energy, it is about using the types of electromagnetic waves. Okay. So there is a form of energy that can travel through space at the speed of light. So this is what they are showing you in this picture over here. This kind of energy travels in waves that have some properties of electricity and some properties of magnetism. That is why both of the properties combine together. They are known as electromagnetic waves. Okay, because these type of waves, what do they contain? They contain the property of electricity as well as the magnetism. Okay, ladies. So that is why together they are known as electromagnetic waves. And as these waves make up rays of light and heat, this form of energy is sometimes called the radiation energy. Okay, so these waves, what do? They not only help in the production of light, but also they produce heat at the same time, light and heat. And this form of energy which is produced with the help of these electromagnetic waves is known as radiation energy. Okay, so there is a huge range of possible wave sizes or wavelengths for this radiation energy. As you can see in this picture, this is the wavelength which is shown for the various types of waves. Okay, so if you can see for radio waves, the wavelength is somewhere from 10 to the power of 4 to 10 to the power of -1. Okay, so this is the same picture you even have in your textbook on page number 220 if you can check. So over here they are explaining about the radiation energy of the radio waves, microwaves which you use in our microwave, then infrared radiation. What is infrared radiation, sweeties? Have you ever heard of infrared?
Yes, I think it's the one that is used in our remote control.
Yeah, in the remote control, and also we use it in the electrical ovens. Okay, have you seen those ovens which have a circuit which get heated up without you even turning on the flame? There is no gas in that, so that heat element gets heated up when you turn it on, and you can cook it on that. So such things, they work on infrared radiation. Okay, and similarly, you know, the ultraviolet radiation from the sun, the X-rays, the gamma rays, all these, they have a particular amount of radiation energy which is emitted with the help of their waves. Okay, and the wavelength, it differs from the radio waves to the microwaves to each type of wave. So electromagnetic waves are split into 7 groups according to their wavelength. Okay, so these are the 7 groups into which they are split into, and the different groups have different properties and different uses. The 2 most familiar groups are the light waves and the radio waves. Okay, so what are the 7 groups the electromagnetic waves are split into? They are radio waves, microwaves, infrared radiation, visible light, which is the light waves, and ultraviolet rays, the X-rays and the gamma rays. Okay, and the most familiar groups which we use are the radio waves, you know, which we use in the radios, Like because of these radio waves itself, whatever is being played in the radio station, that is transmitted with the help of radio waves. Of course, we are not using a lot of radio these days. I'm not sure if you know about it. So before the invention of television, there was only radio which was invented. Okay, so back then people used to get all the news and everything on the radio itself. Okay, so radio had an antenna with the help of which it could connect the signal, and with the help of these radio waves, the information was telecasted at your homes, and you just need to tune it, and that channel can be played. Even now in your car, when you're traveling in your cars and all, you can put on the radio, and you can check out the various channels over there. Do you ever use radio when you're traveling in a car? Ladies? Yeah, this is how the actual radio looks like, which people used to use many years ago, maybe about 50 years I can say, because this was before the invention of television. Okay, so there were these radios. This is the antenna which you can see. So they put the antenna and they start tuning in the channels, and the channels get connected because of the radio waves. Okay, so it's clearly written on that you need to adjust the frequency of the channel. Okay, then the antenna can catch those radio waves, and that particular channel, whatever it is, sports or news or anything, can telecast it at your place and you can listen to it. Are you getting at all what I'm saying, girls?
Yes.
Yeah.
Yes.
Is it clear or is it all blank to you? Are you getting it? Similarly, you can also today use the radio where we are using today is only in our cars. I believe that too, if you're not playing any other Quran or any other music of your own choice. Some people still they play radio when they are in their car. And so they can get whichever channel in that, they can just tune in there, and with the help of the radio waves, the channel gets connected in, and you can see those, you can listen to those sound waves, which are actually radio waves being converted into sound waves. Clear? Hello?
Yes. Yes.
Any questions? Okay,
No.
let me play a video about the electromagnetic spectrum here. Did we watch the video on the electricity generation?
I don't think so.
Yes. Yes.
We did,
Yeah.
isn't it? Yeah, we did. So I will show also a video on the energy transfers, which we are going to do right now, but that is, I believe, a presentation. So let's watch a video on the electromagnetic spectrum. Is the audio clear?
No, miss.
Not hear it?
No.
Okay. Now?
Yes, now it's clear.
Okay.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world
Miss?
you know could not exist.
My screen is frozen.
What is it? Electromagnetic radiation. These
My
waves spread
screen
across
is
the spectrum.
frozen.
Your screen is frozen? Wait, give it about 1 or 2 minutes. If it's still like that, and then you may log in back. The others, can you see it? Can you see the video?
Yes.
Yes.
Yeah. Okay, sweetie. I'm playing it again.
Some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's x-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billionths of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected, and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green. Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared waves. To learn more about the world around us, scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light. Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.
Okay, that was very interesting, and also we got to know a lot of information. Now is it clear to you about how the electromagnetic waves they work? What did you understand from the video? So we are surrounded by a lot of waves, right? So not only we are when we are using our the laptops or your mobiles, you're right now attending the lesson. So there is Wi-Fi, so which is also an electromagnetic radiation, and of course we are using a lot of microwaves. And whenever we are watching TV, however we are using our remote control or the type of equipment we have in our house, right? So the way the waves are reaching to you when I'm talking over here is also because of the type of the electromagnetic waves, isn't it? So these electromagnetic waves, exactly like the ocean waves, they move up and down like this. They have a crest and a trough. Yeah. So but the ocean waves, they pass through water, whereas these electromagnetic waves, they can pass through vacuum. Okay, that is why they can travel through vacuum anywhere, and they are as fast as light. As fast as light travels, these electromagnetic waves can travel. That is why when I'm talking to you over here, you can listen to it at your place immediately, isn't it? So this difference between these two crests is known as the wavelength, and depending upon the difference between these two crests, each and every type of the wave over here has a different wavelength. Okay, so the wavelength for some waves like radio waves, it is very large, or you can say the wavelength is more compared to the type of the gamma rays, for which the wavelength is very, very small. Okay, so be it the type of gamma rays or X-rays the doctors or the scientists are using in order to study the various things in detail, or be it the infrared radiation or the microwaves or radio waves, we are surrounded by a lot of electromagnetic waves. Is it clear, ladies? Any questions?
No.
No.
Okay, I want you to just tell me briefly as to what you understood about the video within a minute now. Give me a moment. Okay, ladies, that's it. You want to explain about the video quickly, anyone within a minute, or shall we move on?
Yes, actually, in the video, it explained more about the radio waves, and it says that there's something on the street. I don't know what is it called, but it's the one that like sends radio
What on the
waves.
screen? The TV?
No, are those long things? What are they called? The ones for the electricity, I think.
The waves?
Yeah.
Which ones are you talking about? Yeah, the waves they were talking. He was talking about the types of waves which we are surrounded by. This one?
Yes.
Yeah, these are the electromagnetic waves itself, which we are getting from the TV. So whenever we are putting any channel, so these are the waves itself which are traveling through whichever channel we are playing, and through the TV we can listen to whatever is being transmitted there, isn't it? So those are also the electromagnetic waves which we get it in our place in Jeddah over here because of our discs. You know the various discs which we have on top of our buildings, or even the cables through which these electromagnetic waves they are connected to the TV, and they catch these signals, these dishes, and that is how this particular channel it is being transmitted on our TV. It is because of these electromagnetic waves.
And also for the radio. As it said, for the radio, as I told you, there is something on the streets, the one that we always see on the streets, the big ones.
Under what?
For the radio to be working, I think. Yes, there are like big things on the street.
Antenna?
Yeah.
Yes. So that is which captures the electromagnetic waves, isn't it?
Yeah. Yes.
Yes. Okay, so this is what was explained. Anything else you want to talk about, Hannah Tawfiq?
Several kinds also of light waves also.
Yes.
And the ones that come from the sun.
Ultraviolet rays, yes.
Yeah. And what else? I think, only.
Yeah. So these are the types of rays or waves which we are subjected to in our day-to-day life, isn't it? The ultraviolet rays from the sun, and of course it is the light, the visible light due to which we can see everything clearly. Also, when these rays they reflect on the cornea of our eye, how it works and how can we see the various colors. All that we will discuss about when we are talking about the structure of the eye and how this works in physics itself in your higher grades, inshallah. So this is how the visible light works. And of course, we also discuss how the microwaves also work because of the microwaves, which is also an electromagnetic wave. And of course, the radio waves, and in TV, all these are the types of the electromagnetic waves which are traveling at the light of the speed in the vacuum. So now we'll discuss about the energy changes as to how one type of energy it is converted into another type. Okay, so we use energy in many ways. For example, to cook food, light our homes, and move cars and buses. So all this is a type of energy which we use. Yes, we use various types of energy which is converted from one form to other form for the various things in our life, in our daily activities. To cook food, we need the gas, isn't it? Or electricity if your oven is an electric oven. Similarly, we need electricity in our homes in order to light the bulbs or the fans or the ACs or any electrical equipment, we need electricity. Similarly, our cars and buses, they work on the fuel, yeah, or sometimes the electricity, the solar energy. So any type of energy which we are using in our day-to-day life is actually we are getting from one source and then converting into the other form of energy, right? So when energy is used, it always changes from one form to another, and some always changes into heat energy, right? Because heat energy is the most common type of energy which we use. For example, when you switch on a light, electrical energies change into light energy and heat energy, isn't it? So whenever we turn on the switch, the electricity is what we are turning on, and with the help of this electrical energy, the light bulb, it glows, isn't it? Giving us light. And we discussed already that wherever there is light, there is also some heat which is produced, isn't it? Because light and heat, they are produced at a time. So when you play a guitar, chemical energy in your body is changed into movement energy and sound energy, because you're trying to use your hand in order to move the strings, which produces the sound, isn't it? So over here, your body's chemical energy, it is changed into movement energy when you're moving your fingers, and this movement, it is producing movement in the strings which produce the sound. So this energy is being converted into sound energy, isn't it, girls? So we'll discuss clearly about the change in the energy as to how one energy is converted into another form in our next class, inshallah. Do you have any questions so far? Any doubts or questions?
Is there any homework?
Yeah.
No, alhamdulillah.
Thank you so much. Page number 74 and 75. Till which question did you do as homework in physics, ladies?